And good afternoon, everyone. Hello there. Welcome to the Academy's Morrison Planetarium, which, along with the Academy and Golden Gate Park and all of San Francisco, is located on the traditional unceded homeland of the Ramaytush Ohlone people, who are the original inhabitants of the San Francisco Peninsula. This is our final planetarium show of the day, and it's the most fun for a lot of our staff. It's a tour of the universe, and I'd like to find out how many of you have seen our other shows earlier in the day, Dark Universe or Expedition Reef. Okay, quite a few. This show is very different. It's a live presentation, and it involves piloting our way through a digital model of the entire universe. So you're going to hear my voice throughout, and I will fly us from Earth out through the solar system, through the galaxies, and out to the edge of the observable universe, and come back by 5 o'clock, because that's when the museum closes. And because it is a live flight, I do want to mention that in case the immersiveness of the planetarium environment makes you feel a little funny, because the image goes way out to your peripheral vision, if you start to feel a little disoriented, just close your eyes for a minute or so, and that sensation should go away, and hopefully you'll be more comfortable after that. As with all of our presentations, we'd like to ask that during this next half hour or so, you please refrain from eating, drinking, snacking, or any kind of photography or recording. And this would also be a great time to silence your personal electronics and tuck away any light-emitting devices like cell phones, tablets, cameras, etc. That light can be very distracting for people sitting around you in the dark and could possibly interfere with the images that we project onto the dome overhead. Now, at the end of the show, we ask everyone to please exit out through the doors at the top of either stairway. If any of you might have some problems coming all the way up the stairs, just stay in your seat and our staff will assist you up the lower exits if that's more convenient. But if you can't, please use the doors up here at the top. And with that, we're going to start our journey into outer space. Now, we're going to first transport all of you through time and space to another place here on Earth, to a place where we actually do begin many journeys into outer space. And first, we get set up here and get everything done just right. And we're using a very special piece of software today that is going to be our vehicle in our journey. And it's a piece of software that is actually available for a free download. It's supported by NASA. You can install it on your own computer at home if you've got the right kind of computer. A good graphics card is required, but if you want to try it out, come and see me after the show and I'll tell you how you can get it. So if you like what you see here, come and see me. So we're going to start our journey by moving from California to the other side of the country, and we'll begin right here. One famous astronomer once said, outer space is not that far away. It's only an hour's drive if cars could go straight up. And yeah, that's true. I mean, now modern rockets can make the trip in about 2 or 3 minutes, but the official boundary of outer space is about 62 miles or 100 kilometers. Most of the aeronautical community likes to use a nice round figure of 100 kilometers, but that's about the distance from San Francisco to San Jose or Santa Rosa. So it's not really that far. You can make that drive in about an hour or so. We are over pad 39A, which is where a lot of space missions begin. And in fact, tomorrow morning, NASA is going to launch a very special mission from this pad at about 7:15 Pacific time. It's going to be a mission that'll take 6 years to get out to the asteroid belt, and it's going to explore an asteroid that is believed to be made largely of metal. So that is a very fascinating mission called the Psyche mission. And that begins tomorrow morning, fingers crossed, at about 7:15 Pacific time. And it'll take 6 years to get there, and we'll spend another 2 years orbiting that asteroid to learn what we can about it. But we're 1 kilometer above pad 39A, and we're going to multiply that now by about 100 times to get up to the edge of outer space. And why is 100 kilometers the definition of outer space? Well, it was calculated out in the 1950s that at that altitude, the air is so thin that air control surfaces like wings, flaps, rudders, those don't work because there's just nothing to work with. So up this high where wings don't work, you have to use rockets to maneuver. And so this is technically the beginning of outer space. Now, for some purposes, NASA uses other distances depending on what they're going for. For astronaut wings, NASA uses 50 miles, which is a little bit less. However, for most of the space community, they use 100 kilometers or 62 miles. So that's the altitude where we are right now. But we're going to go a little bit higher than that because there's not a hard boundary for outer space. The atmosphere expands and contracts, and so it varies a little bit functionally. So we're going to go up to a safer altitude, a little bit higher than this. We're going to go up 4 times higher than 100 kilometers, so 400 kilometers, or roughly 250 miles. And that is where the International Space Station orbits. That altitude is right here, where we've got a nice view of our planet as it rolls beneath us. The International Space Station is the farthest distance from Earth that humans currently travel. There are plans to go a little bit farther. But on the space station, you've got a grand view of the Earth. You're traveling 17,000 miles an hour. You can circle the planet once every 90 minutes. So this is a really beautiful place to be if you like looking at the Earth from high overhead. But we're going to go even farther than this because I said this is the farthest that humans currently travel. We're going to go about 1,000 times even farther still, because the very farthest away from Earth that humans have ever traveled is 250,000 miles, about, again, about 1,000 miles higher than the altitude at which the International Space Station orbits our planet, and it is the distance to the moon. So we're going to have a look at our satellite, the moon. First, I'm going to find the moon, which sometimes is a little tricky, but there's the orbit of the moon, and I'm going to go to the left-hand end over there where we should be able to see our own satellite. So we'll back away a little bit more, and we're going to travel to that point at the end of the orbit, which you see. So we'll zero in on the moon and then travel to it. And back in the late 1960s and early 70s, it took the Apollo astronauts about 3 days to get to the moon. It'll take us only a few seconds because we can travel a lot faster than they did. But our satellite, the moon, is right here currently, as we see it, in a crescent phase. But I'm going to do something here. You don't normally see this in nature. I'm going to turn off the shadow, actually light up this side of the moon a little bit more so that we can see its full face. There we go. So there's the surface of the moon with uncounted numbers of craters, several hundred, several thousand craters there. And all of those craters are formed by the impacts of asteroids at some time in the past. This big crater in the very center is one called Copernicus. And it measures, just to give you an idea, it measures about 60 miles wide. So that's how big some of those craters are. And others are about the same size. And the very young craters are surrounded by this splash pattern that you can just make out here. And that's called ejecta. And it's the indication of a fairly recent impact. So there's another one down to the lower left down here. And you can see the splash pattern around there. And that means that these craters were formed by the impacts of asteroids or comets at some time in the past. The very, very old craters don't have that same splash around them because they were formed a longer time ago, and they were recently almost covered up by lava, which forms these dark patches on the moon. The lava forms dark areas that are called maria, and at one time, astronomers used to think that those large, dark, flat areas were bodies of water. So they called them seas, and that's the Latin word mare, and they gave them beautiful names like the Sea of Rains, or the Sea of Tranquility, the Sea of Serenity, the Sea of Fertility, and we can make them out today very easily just the difference between the lighter and darker colored areas on the moon. The dark areas are very old plains of dark, hardened lava that bubbled up about 1 billion or so years ago. And the lighter areas are very, very rich in craters, lots of craters all over, which you can see very easily. The moon is one of the more fascinating objects to look at. And we did go there, sent some crews of Apollo astronauts there between 1968 and 1972. And in the next few years, there are plans to send other teams of astronauts via NASA's Artemis program. So keep an eye out for any news about the Artemis project from NASA. That's going to land the next set of humans on the surface of our nearest neighbor in space. So we're going to travel even farther away than this now. And as we do, this is 240,000 miles, or 250,000 miles. It took the Apollo astronauts 3 days to get here. It takes a beam of light or a radio signal about 1.5 seconds to get here. And so we're going to travel even faster than that, faster than the speed of light, which is a very convenient speed to use as a measuring stick to compare distances to objects in space. If we look at our solar system, we see that the moon is about 1.5 seconds away at the speed of light. Incidentally, that's 186,000 miles per second. 186,000 miles per second. At that speed, you could travel around the world 7 times in 1 second. Travel from Earth to the moon in 1.5 seconds, and you can travel from Earth to the sun in about 8 minutes. And so here's the sun over on the left, and Earth and the orbits of the other planets there. You can see how far away they are. The nearest planet to the sun, of course, is Mercury. Then comes Venus. We on Earth are the third from the sun. So we're 93 million miles away, or about 8.5 minutes at the speed of light. So we'll use the speed of light as our measuring stick to see how far away some things are and to compare those distances. After Earth comes the planet Mars. And then after Mars is a big gap in our solar system, which is filled with lots of chunks of debris called the asteroid belt. And there are several 100,000 named asteroids out here, and probably a lot more. Scientists think there may be as many as 1 million asteroids in the entire solar system. And after the asteroid belt come the larger planets. Earth, Mars, Mercury, and Venus are small rocky objects. Now we come to the realm of the giant planets, starting with Jupiter, the largest of all the planets, which is a big ball of gas, as is Saturn here. Jupiter is about 11 times as wide as Earth. Saturn about 9 times as wide as Earth. And then after Saturn come the ice giants. They're a little bit smaller, Uranus and Neptune. And those are the 8 planets that make up our solar system. Just beyond Neptune, there is a region of space that is filled with a lot of other material, kind of like the asteroid belt, only there's a lot more material here, and it's not just asteroids. These objects include comets and other objects called dwarf planets, and this region is called the Kuiper belts, also known as the zone of trans-Neptunian objects, and it's a mess out here. There are objects all over with wild orbits. Those are the comet orbits that we can see going off way out into space, and other small objects which occupy that area just beyond the orbit of Neptune. So this Kuiper belt is another area in the solar system where we find lots of debris. And as we travel away from our sun, let's also look at the farthest vehicles that have ever traveled from Earth. I mentioned where the space station is, about 250 miles up. We've gone to the moon, which is about 1,000 times farther than that, 250,000 miles away. Now let's have a look at the most distant vehicles that have traveled away from our planet. And those are the spacecraft Pioneer 10, which is going off by itself toward the upper right, and then Pioneer 11, Voyager 1, Voyager 2, and New Horizons going off to the left. And these are the 5 spacecraft that have technically left our solar system. They've all traveled beyond the orbits of the most distant planets. The most distant one is Voyager 1, and it has been traveling in outer space for almost 50 years. And those are our most distant emissaries from Earth. But we're going to leave them even far behind as we travel farther out into space. we're going to enter the realm of stars traveling farther out than any spacecraft has traveled, but we're still within the region where our radio signals are still traveling through space. Now, the most distant artifact of humanity is our radio signals. These are signals from early radio broadcasts, radiation from the detonation of nuclear weapons during early tests. And out here, this grid that you see forms a radio bubble surrounding Earth, which is sometimes called the radiosphere, and it's about 90 light years across. That means that for the past 90 years, our radio signals have been traveling out into space, and they've only gone this far out, forming this giant radio bubble around the Earth. Now, here's an interesting point. You can see that there are some stars inside the radiosphere, some that are closer than 90 light years away. These radio signals have been traveling out at the speed of light, 186,000 miles per second, for 90 years. And so we say they're 90 light years out from Earth. A light year, the distance that light travels in 1 year, or about 6 trillion miles. And there are some stars that are closer than that. They're inside the radio bubble, inside the radiosphere. And if there are civilizations living on planets orbiting those stars, maybe they've heard our radio signals. That's an interesting thought. If any civilizations are outside the radiosphere, farther out than our radio signals have gotten, they haven't heard anything. They don't know about us yet. They think they're alone in the universe. But so far, the radiosphere contains about 70, 75 stars. So who knows? Is there somebody there? We don't know. They haven't gotten an answer. And even if they did answer, it'd be a long time before we get that response. It'll take another 90 years for that signal to get back to us. But who knows? As we travel farther out, I'm going to leave the radiosphere on so that we'll use it as a marker to indicate our location in the galaxy. Now, we're passing through the stars that make up our own Milky Way, and up until about 100 years ago, astronomers thought there was only one galaxy in the entire universe, our Milky Way. But almost exactly 100 years ago, an astronomer named Edwin Hubble said he made a discovery that showed that there are other objects farther out than our Milky Way, far beyond the most distant part of the Milky Way. And there are other galaxies out there. Not only are there other galaxies in space, but they're getting farther away. They're moving gradually farther and farther away. So not only was the universe bigger than we had thought, but it's getting even bigger still, thanks to the discovery made by Edwin Hubble 100 years ago. And as you can see, the Milky Way galaxy is a flat disk of stars, measuring about 100,000 light years from one edge all the way across to the other. We on Earth are nowhere near the center. We're off about 2/3 of the way from the center. That's our radio bubble, our radiosphere near the edge. So we're not at the center of the galaxy. We once thought we were, but all these new discoveries of our universe changed our minds about that. And we're going to see that there are other galaxies surrounding ours, and they go even farther out than we can see. The Milky Way is one member of a small cluster of about 30 galaxies called the Local Group. And that group also includes another large spiral like the Milky Way. It's called the Andromeda Galaxy. And it and the Milky Way are the two largest members of the Local Group. But there are other galaxies out there. Now, everything you see, because we've left the galaxy now, so everything you see is not a star, but every point of light you see up there on a dome is a galaxy. It's the location of a galaxy based on actual surveys that have been taken of the locations of various objects in space. And they're not really these colors either. It'd be nice to think of that the universe is so colorful, but the colors just indicate the particular surveys that detected these galaxies. So the galaxy, the universe is probably not quite as colorful as this, but you can see there are thousands and thousands of galaxies out there, and some are clustered into giant groups of thousands of members called superclusters. And between the giant clusters, there are just empty spaces, empty voids where we don't find very much at all. But we're going to travel even farther out now, even farther, certainly farther than any spacecraft has gone. No spacecraft has left the Milky Way galaxy, but we're now out in the realm of the galaxies, and we can get an idea of the distribution of galaxies in the entire universe. As we back away, where our map of the universe is coming into view. And you can see how galaxies are clustered together, forming clumps and tendrils, and they're separated by empty spaces or voids. And we're going to get a look at the big picture. This is our current map of the visible universe. And it might strike you as rather strange because it looks like a giant butterfly or like a giant bow tie, but that's not really the shape of the universe. That big area between the two fans that go off in opposite directions, that's not empty space. That's just part of the universe that we haven't seen very well yet because there's something in our way. What's blocking our view in this area here is all the dust and gas along the plane of the Milky Way galaxy. Remember earlier, the Milky Way was seen as a flat disk, and looking along the disk, that is blocking our view of other galaxies that are undoubtedly out in these regions. That, again, not empty space, but just areas we haven't seen very clearly. Eventually, our technology will get good enough so that we can see, and our map of the universe will fill out a little more uniformly. We're beginning to see a few galaxies in this area, but we'll get better at it. And as we get farther and farther out, we'll come to some of the most distant objects ever detected. These objects are called the quasars, or quasi-stellar radio sources, and those are represented by the orange dots that you see at the ends of the fans. The quasars are very, very energetic objects, and they're known to be extremely distant, in the neighborhood of about 10 billion light years away. So far away that their light takes 10 billion years to reach us here on Earth. For them to be as bright as they're seen, they've got to be tremendously energetic. And astronomers think that quasars are the centers of young newborn galaxies powered by the emissions of supermassive black holes. So those are the most distant single objects that we've seen, but there's something even farther out than that. The most distant phenomenon detected, the edge of the visible universe, is represented by this mottled orange pattern, which comes seen in all directions. This represents a radiation that comes from all directions, permeates the entire universe. It was predicted in the 1940s and was detected in the 1960s. It's called the cosmic microwave background radiation. And it comes from the idea that, well, since the galaxies are all moving apart from each other right now, at some point they must have been a lot closer together. And the expansion of the universe must have begun with some unusual event which caused the galaxies to spread out farther and farther away. That moment was nicknamed the Big Bang as a kind of a joke, but the name stuck. And that Big Bang event is supposed to have happened about 13.8 billion years ago, when the galaxies began to move farther apart from each other. Another way to put that is that at one time, the universe was very hot, very dense, very opaque, and practically a solid. And then suddenly, it just suddenly transformed into something very cool, very transparent, very rarefied, and that is where the galaxies began to form and move farther and farther apart. The colors we see here, that mottling in the background, is actually a map of temperature differences that have been detected. So where some of the material is a few 10,000ths of a degree warmer or cooler than others. And this shows the beginning of what's called the differentiation of matter in the universe, where matter began to clump together. And this is believed to come from a time about 380,000 years after the Big Bang, after the universe began to expand. So this is as far as any instruments have been able to detect anything at all, the farthest we can see into the universe. With that, there's really only one way, one place to go, and that's back in toward the center of our model. This model, in fact, shows us that our knowledge of the universe is not yet complete because there are still gaps. There's still areas where we're not seeing everything that we suspect should be there. So eventually, again, our model of the universe will become more filled out as we detect more and more material out there. But it seems, if you look carefully and pay attention, our model makes it look as if we're at the very center of everything. Everything seems to point toward us. And is that the real shape of our universe? Are we at the center of everything? I know a lot of people who would like to think so, but no, we're not. This is just the result of the fact that we're the ones who made this model. We made the map, so everything is based on our particular point of view. If somebody else in some other part of the universe made their own map of the universe, it would look similar, and it would appear, based on their perspective, that they're at the center of their map. There really is no center to the universe as far as astronomers can tell. But we've seen so many galaxies now, and each one containing so many stars, each one probably like the Milky Way, containing hundreds of billions of stars. How many stars does that make in the entire universe? And around those stars, are there indeed planets that might be something like our own world, our own planet Earth? We don't know the answer to the latter part of that question, but we certainly have detected other planets orbiting distant stars. These are called extrasolar planets or exoplanets. And since 1994, astronomers have detected about 5,500 extrasolar planets. 5,500 stars that are orbited by at least one planet. These circles you see each represent the location of a star. Whoops. Right there. Each one represents the location of a star where a planet has been discovered. And so far, the number is at 5,500. So, and those are just the nearest ones to us. The number keeps going up, so undoubtedly there are many, many more. Are any of these worlds like Earth? That we don't know. We know they're there, but they're so far away. We don't know what the conditions are really like on them. And there are a lot of conditions that need to be fulfilled for a planet to be like Earth. It's got to be made of the right stuff. It's got to be, we think, a rocky planet. It's got to be just the right kind of, or the right kind of star, one that doesn't give off dangerous radiation. It's got to be just the right distance from its star so that it's neither too hot nor too cold, and that would allow liquid water to exist. And it's got to have liquid water. It's got to have the elements that are required for life to exist. So we don't think so far that we have found any planets that are like Earth in that they're capable of supporting life, but we don't know. There might be some out there, but so far we haven't found them. But we're still looking. So that means that in all of our travels through the universe, through the distant galaxies, to the edge of the universe and back, there's no place like home. Our planet is the one place in the universe where we do find an environment that supports life in a very delicate balance with the environment. And so this is a place that we need to take really good care of to make sure that it can continue to support the life upon its surface. And with that, welcome home. Welcome back to the planet Earth, and we thank you all very much for joining us on our tour of the universe.